Hi. In our past Tech and Motion session, we talked about the role of artificial intelligence in DevOps. And in that session, we demoed how an application can effectively incorporate AI within its software and utilize AI prompts within its code base. The demo could be helpful for developers, project managers, or even executives that really want to visualize how a new or even a legacy application can incorporate AI within its app or within its services. I'm Breon Green. I've been with Motion for 5 years, working as the lead DevOps consultant. I spent the last 10 years of my career working specifically in DevOps in the cloud space with over a few dozen organizations across the enterprise, bringing them to the forefront of their DevOps transformation from retail to fintech, healthcare, and government, and even insurance regulation. More recently, I've worked mainly as a strategist, designing and implementing many AI ops platforms, serving the dev and the operations environments across industries. So here's an example architecture of a sample application that logs to AWS CloudWatch. And what this does, it's going to allow us to monitor an app or service logging errors and issue a potential code fix to our code base. It determines the fix by running it against the generative AI platforms such as Amazon Bedrock. And we all face this as developers where we create software that inevitably has bugs, and oftentimes during a sprint or backlog, rather than working on a bug or fix, unless it's a dire need, we generally get out prioritized by product or new feature development. So this provides a way to use generative AI to our advantage and not only recommends fixes that actually, in this case, take it a step forward by fixing them through a pull request. So how this works, in step one, the Lambda error logs process function receives an application error log via Amazon CloudWatch. And in step two, the stack trace is then stored in an Amazon DB table to track its processing state, and each item in the table represents a unique error message. The Lambda function event processor in step three obtains the events from the DynamoDB stream and then sends it to SQS in step four for batch processing. The message is then read and then enable batch processing, and concurrency is controlled by the code optimizer function. That function basically builds a prompt that will construct basically a query in the form of a human question and then provides that modified source code as its response. And in step six, the code optimizer function then commits the modified source code into a new Git branch. And finally, in step seven, the Git branch and its corresponding pull requests are pushed to the source control system via the GitHub API, where a developer or customer or DevOps engineer or even a platform engineer would approve the PR, and then it will trigger the CI/CD process. So again, this could be any custom application that would log to Amazon CloudWatch. The Lambda error logs processing message basically takes that, or an event is triggered, and then takes that uh, code and then pushes it into a database with a unique number. Then the event processor takes that message and constructs it into basically a better, a more readable message for SQS. And then the code optimizer function runs that message, that error message that's logged against Amazon Bedrock. And then if there is an event uh, that needs to be updated, you will see that in the form of a pull request through the GitHub API. So before we get into how the code base works, I wanted to give you an overview and really a high level of what we're expecting. So essentially, this code will run and it will log an event to CloudWatch, which would then trigger all of the pipeline which we showed previously. So again, the application which we're simulating here logs an event to CloudWatch, and then eventually it will get to the point where we are suggesting a pull request for that particular event. All right. And here's an example of how that pull request would look, right? Against the code base that we currently have, you will see a branch created, and then that PR, which is the last PR event that was sent here, would essentially provide a fix, which again is basically the code self-healing itself. So you can take a look at the pull request here. It's actually the one I just kicked off. And you'll see the files that are changed. And essentially what I did is sent or created a function, an empty function that wasn't defined, and it modified the code based on that error message that it received as an exception to the CloudWatch log. And this would basically be the error message. The run my stuff is not defined. And it suggested a fix here of redefining that function and then adding also the function as well, even though it does essentially nothing here. Okay, so let's trigger another event. And this time I'll walk through a bit of the code base and talk through what's happening in each of the steps. All right, so we triggered an event, and again, it's basically just an exception. And through CloudWatch, we will see that event logged. Obviously, the info messages, which is in the code. Here is the info messages. This is an info message. This is an error message. And I sent both of those. And then again, this is what's causing the exception. Because again, the run my stuff is not defined within the Python script. All right. So these are the events that happened in the last minute. And so we have 3 functions, again, showing what's listed here, 1, 2, 3. And each of those functions basically serve the purpose of detecting the error, triaging that error, and then running it against the code base, running that error message against Amazon Bedrock, and then making those changes through the GitHub API. All right, so the self-healing code, we'll take a look at what has triggered within the last 3 minutes since we just kicked it off. And as you can see, this is the first detected message. All right, and it processed successfully, which will basically send that event to Amazon DynamoDB for processing. Okay, and then as we look into each of the other functions, the triage function here. Look to the events in the last few minutes. You'll see that we have that one event. Okay, and then that event, it basically created a record and then sends that into from the DynamoDB as a stream, and then processing to SQS. All right, and then the final piece of code, which actually fixes the issue, which was discovered. 3 minutes. Here it sends it into Amazon Bedrock, and then you would essentially create a prompt in a human readable form. And we could talk a little bit about how that happens within the code itself. Okay. So here's where is constructing that message into a human readable form. Again, the example code in this case would be the error message that we've created from the sample code, and it will construct this in a human readable format. And then the suggested code will be fed in as a fix, which would eventually become a pull request uh, to our code base. So we should just have seen a pull request within the last 3 minutes because we just kicked it off. And here it is. And okay. And again, this is all coming from AI. You could run this against some other CI platform where you would test and make sure that the code is working as intended. If this fix was applied, I could see this use case, you know, being for applications that needed to be refactored in a larger scale. You could, potentially run your code base. Let's say, for instance, you were wanting to port your code from Android to iOS, right? You wanted some suggestions. You could very easily do that and run it against AI and provide those the things that are required for the conversion itself. Um, so all of this is publicly available. I basically created a fork of the guidance for self-healing code on AWS repo. And in order for it to work on this demo, I did do some refactoring of this code. So you can look at my fork. But then also, there is the repository here that I've created to demonstrate how an application, can run alongside this code and detect the fixes that are required, or if you wanted to expand it to use some other features. Even if you were wanting to create a process for your applications to um, interact with a real human, you could very easily refactor this to do so. So definitely give me a shout on LinkedIn. If you have any questions, definitely reach out to me, and hope you guys have a good day. Thanks.